All right. This time we're going to talk about K nearest neighbors, KNN. But before we get started, hit the like button, subscribe, and share with anyone you know who's taking the AWS Machine Learning Associate exam. So, SageMaker's K nearest neighbors implementation takes the classic algorithm and scales it for production use. KNN is an instance-based, nonparametric learning method that doesn't build an internal model using use during training. Instead, it memorizes your data and makes predictions based on similarity, a conceptually simple approach that SageMaker optimizes through advanced pre-processing and indexing. The algorithm uses dimensionality reduction and sign or random projections to handle large datasets in high-dimensional spaces efficiently. This engineering makes KNN practical for real-world problems where that naive approach would fail. So, how does this work? So the algorithm measures distance between a query point and all training points. It selects the K nearest neighbors based on that distance, then returns either the most frequent labeled for classification or the average value for regression. SageMaker enhances this basic approach with dimensionality reduction to combat the curse of dimensionality and approximate nearest neighbor search for performance at scale. These optimizations let you work with datasets that traditional KNN implementations couldn't handle. So, when to use it? All right. KNN excels when you need fast, interpretable results with well-structured tabular data. It's ideal for quick prototyping and establishing baseline models. Common applications include customer segmentation, house price prediction, content recommendation based on user similarity, and real-time fraud detection through batch inference. All right. So data formats, right? So SageMaker KNN accepts CSV or RecordIO Protobuf formats. For CSV files, place the label in the first column with the features in the remaining columns. RecordIO Protobuf is recommended for large-scale, high-performance jobs. Both file and pipe modes are supported. You can configure a train channel, which is required, and a test channel, which is optional for accuracy for the evaluation. All right. And these are some of the hyperparameters you might be able to look for. Okay. So the hyperparameters, these are going to be the number, you're going to have a couple of different ones, right? K, the number of neighbors to consider. This is your most important. You start with 5, adjust based on your results. Sample size controls how much of your data set gets used during training, directly affecting memory usage and speed. For high dimensional data, set dimension reduction to sign or face to reduce future dimensions and improve performance. Let's go into the console. We're in SageMaker AI. Remember S3 to load your data. Go down to training, click training jobs, which are already out. Click create training job. And we'll do KNN/test. Select the appropriate IAM role for security, or you can create one. Okay. And then you go to the built-in algorithm. Tabular, K nearest neighbors. All right. Use file mode for local, pipe mode for directly from S3. We'll just have it select on there. All right. And then you're going to go for your compute. So you typically want to go for an ML M5 or better. Right. So you can see these are already selected. So this will handle most of this effectively. You can also use GPUs. So ML.P. This is for faster pre-processing, but it's not strictly necessary, right? So for inference, GPUs can provide a higher throughput, while CPUs will offer lower latency. Basically, choose based on your requirements. And the model size will depend on your sample count and feature dimensions, but you can keep costs down by using pipe mode for large data sets. And you should stick with the ML M5 series, right? Unless you need GPU acceleration, then you can reduce the sample size to avoid excessive memory consumption. Excuse me. So you prepare that data in the CSV or the Protobuf format. Go down here, select your encryption type, or if you do or don't, we're just doing this as a prototype, so you don't really need it. Network isolation with the VPC, security groups, subnetting. And we talked about the configuration of the hyperparameters. Talked about the sample size. We start with 5. All right. And then dimension, reduction type, sign. Oh, oops. Oh, that's the reduction target. Sorry. Reduction type. There we go. Sign. All right. And then I think that's good. All right. So we got this all configured. We choose the input from the S3 with the pre-trained data or prepared data, pipe or file mode. Then we check whichever ones we provided here. So let's just say for that compressed file type with pipe mode, that would work. RecordIO, now unencrypted or unzipped. Enter the S3 notification, checkpoint notification for saving. If you're using the managed spot training, then your output bucket, your key value pairs. Click create training job. All right. So from there, you'll be able to monitor its progress in the console. And once training completes, you can deploy your model by selecting the create model, deploy it to the input, and make it available for predictions. Close that. Close that. Okay. And then you'll see how it integrates. So this is one with OpenSearch. Let's see. So what else does it work with? So KNN integrates with a lot of AWS services. S3 for your training and test data, along with your outputs. SageMaker Pipelines can automate your machine learning workflows end-to-end. CloudWatch to monitor training and inference performance. OpenSearch over here to scale. And then SageMaker Model Registry for versions of your trained models for governance and rollback. All right. So a couple of things for the exam to remember. KNN is instance-based and non-parametric, right? It memorizes data rather than learning parameters. It handles both classification and regression tasks. The K parameter controls how many neighbors influence predictions, K nearest neighbor, all right? That makes sense. SageMaker adds dimensionality reduction and approximate nearest neighbor search for scale. GPU training is optional, but can speed up pre-processing, though it does increase costs. Then you remember the two file formats are CSV and RecordIO Protobuf. So this is good for ideal prototyping and baseline models with the tabular data. So remember for the exam, questions about simple interpretable algorithms for tabular data with quick baseline models or instance-based learning, K nearest neighbor is your answer. All right, so we're gonna be done with this. But before we get going, hit the like button, subscribe, and share this with anyone you know taking the AWS Machine Learning Associate exam. Thank you, and have a good day.